How are you, my friends? This is lecture number 30 of the pre-calculus course, Nonlinear Systems of Equations. Please, you can see the other lectures on this playlist down here. Now, the objectives in this lecture will be defining the nonlinear system. We will see three methods of solving these systems by substitution, elimination, and by graphing. What is a nonlinear system? A nonlinear system is a system in which at least one equation is not linear. So we can have 2 equations, 3 equations, 4 equations, 10 equations. If one equation at least is not linear, we call it nonlinear, like this one here. See, the second one is linear, the first one is not linear. Same thing here. Now let's solve the nonlinear systems. X squared, the first one, plus 4x minus y is equal to 8. 2x minus y is equal to minus 16. Let's use the substitution method. Substitution method, you can see that in lecture 29 in details. Let's start with equation 2 because it's easier and solve for y. So take y on the other side, bring 16 on this side, y would be 2x plus 16. Let's call it star. Now we can substitute or replace this equation star in equation number 1. So we can have x squared plus 4x minus, you need a bracket here. That's the y there, is equal to 8. Just simplify the equation. 4x minus 2x is 2x minus 16, and there is a minus 8 from there. Minus 24, factor it. X plus 6x minus 4, we have two values for the x. Now, to find the y, just easily go to star here. You see this star? So if x is minus 6, we put it in the star, then y will be 4. And if x is 4, we put it in the star equation, then y will be 24. So we have 2 points in the intersection, minus 6 and 4, 4 and 24. We have to check each solution in each equation of the system for non-linear, please. So in this case, we have 2 solutions, 2 points of the intersection. Now, when we have, this is like the example we did now. This is a parabola and a straight line. Sometimes we have one solution. See, when you have a parabola like this and a straight line, in some special cases, there is 1 point in the intersection, or sometimes there is no solution because the parabola and the straight line, they do not intersect. Let's see 1b, x plus y is equal to 0, x cubed minus 5x minus y is equal to 0. Let's take the easy equation, number 1. X plus y is equal to 0. Solve for y, y will be minus x. Let's call this one star. Now we replace star in the second equation. So x cubed here, minus 5x minus, see the minus here, in the bracket, minus x is equal to 0. Simplify the equation, we get cubic. X cubed minus 4x is equal to 0. Factor x as a common factor, then there is a difference between 2 squares. So we can see there are 3 values for the x. X equals 0, x equals minus 2, or x equals 2. Now, in the next slide, we have to replace every value for x here in the star to find y. Now we find if x is 0, y will be 0. If x is minus 2, y will be 2. If x is 2, y will be minus 2. We check in each equation, then the solutions are 3 points. I put the graph here just as an extra stuff. You can look at it, the intersection between this cubic equation and the straight line. There are 3 points in the intersection. This is not easy question. Let's solve this nonlinear system. We have x squared plus 3xy plus y squared is equal to 22. X squared minus xy plus y squared is equal to 6. You can pause the video if you like, please, for a minute or so. Try it and see what can we do. If you are ready, let's go to the solution. All right, we have to find an equation, star equation, as usual. So let's use first elimination. Let's eliminate We can here eliminate y squared, x squared at the same time because we can make them with opposite coefficients. So let's multiply the second equation by -1 here. You see minus, this becomes plus and minus 6, and then add. When you add these two equations, you get 4xy is equal to 16, divide by 4, xy is equal to 4, find y, 4 over x. This is a star. Now we can substitute now star in equation 2. So I can say x squared minus x, this is the y, 4 over x, plus 4 over x squared is equal 6. And you have to do some work here. From algebra, you have to work with the equation, rearrange it, simplify it, x squared, and you can cancel the x here, minus 4 plus 16 over x squared is equal to 6. Multiply both sides by x squared. So the LCD here is x squared. We can multiply, we get x power 4 minus 4x squared plus 16 is equal to 6x squared. Rearrange it again, and then we get x power 4 minus 10x squared plus 16. We need to factor. Now we have x squared is equal to 2 or x squared is equal to 8. Remember here. Now, continue the next slide to see the x values. There are 4 x values. If x squared is equal to 2, take the square root of both sides. X will be plus or minus square root of 2. And here x will be plus or minus 2 square root of 2. Now for each x, go to star and find y. And then you have to check. I did not write it here, but you have to check easily. And then we have 4 solutions there, 4 points of intersection. Another nice question here. Let's solve the nonlinear system. X squared plus y squared is equal to 5. 4x squared plus 3y squared is equal to 11. Now, if you look at the solution of example 3, we can see that we can use elimination method here to cancel either x squared or y squared. Sometimes we can use substitution method as we did before, or in some other examples, we can use both methods at the same time. Let's decide here to cancel x squared. So I have to multiply the equation 1 by minus 4. Remember to multiply on both sides, even 5 times minus 4 will be minus 20. Let's add the equations. We cancel the x. Here we get minus y squared is equal to minus 9. Multiply with minus 1. Y squared will be 9. You can find y from here, plus or minus 3. Now, this example is a little special. We will replace y squared is equal to 9 in equation 1, and we will see some kind of a surprise. So it will be x squared plus 9 is equal to 5. X squared will be minus 4, which is not acceptable. This is positive number. This is a negative number. If you find x, you get a complex number here, plus or minus 2i. So no real solution, which means that the two graphs, they do not intersect. See the graph of the first one, x squared plus y squared is equal to 5. This is a circle here. And the second one, 4x squared plus 3y squared is equal to 11 is an ellipse. They do not intersect. I put this graph as an extra tool so that you can see the solution. Example 4, an application. Find two numbers whose ratio is 3 to 2 and are such that the sum of their squares is 52. So here we have to start by letting x and y as the first number. So we say let x be the first number, let y be the second number. So the ratio x over y is 3 over 2. And the sum, we add the squares. You see the square of each? X squared plus y squared is equal to 52. Now we have equation 1 here, and we have equation 2. So this is a nonlinear system. From equation 1, which is easy, 3y cross multiply is equal to 2x. So y will be 2x divided by 3. Let's call it equation star. Replace this star in equation 2. So I put here x squared. 2x over 3 all squared is equal to 52. So this will be 4x squared over 9. Let's multiply by 9 on both sides to simplify the equation. So let's multiply by 9. I can leave now the 9 with the 52 because there will be a cancellation here. So 9x squared plus 4x squared is equal to 52 times 9. You can add these two, 13x squared. I know the 52 is 13 times 4, so I can cancel the 13. So this is a little trick here. Without multiplying and dividing, you can leave it for a minute and then cancel the 13. 4 times 9 will be 36. So that's easy number now. X squared will be 36, so x will be plus or minus 6. So we can take the first x equal to 6 in star here, and y will be 4. If x is minus 6, y will be minus 4. So the two numbers are 6 and 4. These are two numbers, or minus 6 minus 4. He did not say positive or negative. Now let's look at another. Solve the nonlinear system. X squared plus y squared is equal to 16. Absolute value of x plus y is equal to 4. Let's see how many solutions are there. Let's start with equation 2 here. Absolute value of x is equal to 4 minus y. See, take y on the other side of equation 2. Let's square both sides. Now here you have to be careful, please. Absolute value of x is equal to 4 minus y. When you square this and you square this, we know from algebra that when you square the absolute value of the x, this is the same as squaring the x itself. Both are positive. Remember this rule. So instead of absolute value of x all squared, I can leave only x squared. And this one, 4 minus y squared, I have to use the formula. Remember the formula, a minus b all squared. A squared minus 2ab plus b squared. So this is 16 there, minus 8y plus y squared. Plus the other y squared there is equal to 16. Now rearrange the equation and try to find the y. When we arrange the equation, we will get 2y squared minus 8y is equal to 0 because this 16 here will be cancelled. Then divide by 2, we get y squared minus 4 is equal to 0. Take y as a common factor. So y times y minus 4 in the bracket, y equals 0 or y equals 4. Now back to equation 1 or 2, we need the x value. If x is equal to 0, then x squared will be 16. So x will be 4 or minus 4. That's two solutions there. If y will be 4, x squared will be 0, so x will be 0. So now we have here three solutions. We have to check each solution, 4, 0, minus 4, 0, 0, 4. And I put here the graph as usual as an extra tool so that you can see the two graphs, they intersect in 3 points. Find the number of solutions of the nonlinear systems. When we say find the number of solutions, usually it's not easy to solve the system by algebraic ways. So what can we do here? We go to method number 3, we try to graph it. So we graph this equation here, we graph this equation, and we look, just by looking, how many points in the intersection. So the number of points in the intersection will be the number of solutions. So it can be 1 point of intersection, 2 or 3, or maybe 0 if we have no intersection in the graphs. Let's see part A. Now, part A, we have y equals 1 minus 5 to the power x. That's an exponential function, remember? And this is a normal straight line, 2x minus 3y is equal to 6. Let's graph both equations. So the first one is exponential increasing because the base is greater than 1. Then this is reflected in the x-axis, shifted up 1 unit. The second one is a straight line. We find 2 points. If you put x here 3, so y will be 0. If I put x equals 0, y will be minus 2. So this is 2 points to graph the straight line. Then you will see the graphs like this. So this is exponential, reflected, shifted up 1 unit. See, we see here 1 point. We don't care now what is x, what is y. It can be any number, but we know there is 1 point. So the number of solutions is the number of intersection points. So the answer here is 1. 1 point in the intersection. Can you try the second one, please? Maybe the second one is harder. Before you see the solution here, y equals log of minus x plus 2. And here we have x equals square root of 9 minus y squared. You can try it, please. Graph the first, graph the second, and see how many points in the intersection. Okay, ready? Let's go to B part. B part here. The first one is a logarithmic function increasing because here the base is 10. If we don't see the base, that means it's 10. Reflected in the y-axis because we have a minus x and shifted up 2 units. This one is a little tricky here. X equals square root of 9 minus y squared. That's half a circle because x is equal to square root, which means x is positive. Now the complete circle, remember, complete circle, we should have an equation like this. X squared plus y squared is equal to 9. That's a complete circle. And this one is half a circle. No intersection. See, this is positive x. Positive x is in quadrant 1 and 4. So that's half the circle here. And this is logarithmic function increasing, and it is reflected. See, the basic was increasing like this. And then this is reflected in the y-axis, shifted up 2 units. So the whole graph on this side, on the left side of the y-axis, the whole graph, and this graph on the right side of the y-axis. So we see, so the black is the first equation and the red is the second one, half a circle. So what is the number of solutions? 0. That means no intersection points. Let's go back to algebraic way. Solve the nonlinear system. Log of x plus log of y is equal to 3 over 2. Second equation will be 2 log of x minus log of y is equal to 0. I think this is so easy. By looking, you can directly add the equations and use elimination. Just add the equations, they are ready. You don't have to multiply by anything. So when you add, you get here 3 log of x, and this is canceled. 3 over 2 plus 0 will be 3 over 2. Multiply here by 1/3 on both sides. We have log of x is equal to half. So let's find x. Now the LE rule, remember, from log, we can go to exponential. So x will be the base here, 10 to the power half. So x will be square root of 10. From logarithmic, we can go to exponential. We call log exponential rule. Now we substitute x here, x equals square root of 10 in equation 2. So we have 2 log square root of 10 minus log of y is equal to 0. So log of y here, this is 10 to the power half. You bring the half down, so it will be log of 10. Log of y is equal to log of 10, so y will be 10. Because when we have equation with 2 logs, then the arguments here are equal, y is equal to 10. So the solution here, square root of 10 for the x, and for the y it is 10. We must check in both equations, equation 1 and 2. Let's see another nonlinear system. X plus square root of y is equal to 0. Y squared minus 4x squared is equal to 12. So let's call it equation 1 and equation 2. Take the easy equation, which is number 1, solve for x. So x will be minus square root of y only. Now let's square both sides here. When you square x, it will be x squared. When you square all this with the minus and square root of y will be y. Let's call it equation E. So let's substitute now equation E in equation 2. We have here x squared. So I put here, instead of x squared, I put y. And I have already y squared minus 4. Y is equal to 12. Let's rearrange the equation, factor it, and find y. Y plus 2, when you factor this, y minus 6. Just be careful here. See, when you multiply, you get minus 6 plus 2. This is minus 4, correct? And plus 2 minus 6 is minus 12. Now, when you check the y values, see, we have square root of y. We cannot accept any negative y. This one is rejected. See, that's a little trick here. This one is rejected. Y equals 6 is accepted. So if y is equal to 6, I put it here, and then x will be minus square root of 6. So the only solution is x will be minus square root of 6, y will be 6. That's the solution. Example 9, find the number of solutions of this nonlinear system. We need only the number of solutions. Now, this is not easy to graph, so we can try by algebraic ways. Look at the equation here. 3x squared plus 2xy minus y squared is equal to 4. 4x squared plus xy minus y squared is equal to 4. Can you take a minute, please, to try? These are not easy questions. You can try them, please. When you're ready, you can go to the solution. Now, here we have x squared, 3 and 4, the coefficients, xy, different coefficients. We see minus y squared, minus y squared. So we can multiply, let's say, equation 1 by minus 1. See, multiply equation 1 by minus 1, then add the equation. So this becomes minus here, this becomes minus, this plus, and this is minus 4. So when you have a minus 3, when you add, you get x squared. See, 4x squared minus 3x squared. And there is a minus here, so it will be minus xy. This will be canceled, because now this will be plus on the equation 1. And this is a minus 4. With the 4, it will be 0. Now let's factor this easy equation. X is a common factor, x minus y. The product is equal to 0. That means x is equal to 0 or x equals y. So I will call this star 1 because I have to use it separate. And I will call this star 2. Now substitute equation star 1, which is x equals 0, in equation 1, and we will see what will happen. We substitute equation star 2 in equation 1, and we will see what will happen. So from the last slide, we see x equals 0, we call it star 1, x equals y, we call it star 2. If we substitute equation star 1 in equation 1, we will get minus y squared is equal to 4 because x will be 0, this will be 0. So multiply with the minus, you get y squared is equal to minus 4, which is rejected because this is a positive number, cannot be equal to a negative number. Now let's substitute equation star 2 in equation 1. So x equals y. So every y here and there, I will put x. So we get 3x squared plus 2x squared minus x squared is equal to 4. So when you add here 5 minus 1, it will be 4x squared is equal to 4, divide by 4, x squared will be 1. Take the square root of both sides. So we get either x plus 1 or x minus 1. You see that? If x plus 1, then y will be plus 1. If x is minus 1, y will be minus 1. You have to check the two proposed solution, 1, 1, minus 1, minus 1. And now the two are acceptable points. So these are the solutions, 1, 1, minus 1, minus 1. Now in this lecture 30, you can find 3 parts of practice questions. Part 1, 3 questions, and the solutions will be in one video. Part 2, 3 questions, and their solutions will be in another video. You can see that. Part 3 will be 6 old exams questions. The solutions will be in another video. So you have many questions here to practice, almost 12 different from the examples. Let's see quickly here. Part 1, we have 3 questions, nonlinear systems. Solve this: x squared plus xy is equal to 1, xy plus y squared is equal to 3. Please try them before you see the complete solution. Question 2, you need to factor here by little thinking. X minus y is equal to 3. X cubed minus y cubed is equal to 117. Try, please. And this one is not easy. Maybe you need time. 2 to the power x plus 2 to the power y is equal to 10. 4 to the power x plus 4 to the power y is equal to 68. Maybe this is the most difficult one in this lecture. Now, the solutions here, only the answers are there. For complete solution, you can see nonlinear systems, part 1, extra solved questions. You can see that. Now, part 2 is another equations. Here we have system, x plus 3 squared plus y minus 4 squared is equal to 20, x plus 4 squared, y minus 3 squared is equal to 26. Try to expand here the idea and then continue. Question number 2, we have x squared plus 2xy minus y squared is equal to 1, x squared plus 3xy plus 2y squared is equal to 0. We did similar, but this is a little tricky. So try, please. And number 3, we have 3x squared plus 2xy minus 5y squared is equal to 11. X squared plus 3xy plus y squared is equal to 11 also. Now, the answers, as usual, here are the answers for the 3 systems. For complete solution, you can see nonlinear systems, part 2, please. Extra solved questions. And now we go to part number 3. 6 old exams questions. Let's see number 1. Solve the nonlinear system. 2xy plus 1 is equal to 0. X plus 16y is equal to 2. That's a medium question. Find the number of solutions of this system. Y is equal to 6 minus x. And the second one, y is equal to absolute value of ln of x minus 3. This is base E, logarithmic. This is a nice question here, not long. If this system, x squared plus 3xy plus y squared is equal to 22, and x squared minus xy plus y squared is equal to 6 is converted to the equation ax to the power 4 plus bx squared plus c is equal to 0. Let's find the value of a plus b plus c. So here you don't have to continue solving the system. In the middle somewhere, you will have an equation like this. When you reach that, just take a coefficient, b is the coefficient, c is the constant, add a plus b plus c. Here, this is a little application. Find the sum of 2 positive numbers whose squares have a sum of 100 and a difference of 28. Try to translate, please. This one, I would say above average. If AB and CD are the solutions of this system, 10x squared plus xy minus y squared is equal to 16, 7x squared plus 2xy minus y squared is equal to 16 also. Find the value of A times B times C times D. So simply, you have to solve the system. Usually you will get 2 solutions, which is 2 points. And then you multiply A times B times C times D. Oh, the last one here, 6. A right triangle has an area of 3 feet squared. So you have a little application also here. And the hypotenuse, square root of 13 feet. Then find the sum of the other two sides. So the sum can be 7 or 5 or 8 or 6 or 9. Now here are the answers for the last 6 old exams questions. For complete solution, please, you can see Nonlinear System of Equations, Lecture 30, Pre-Calculus Old Exams questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. Just to remind you, this is Pre-Calculus course, lecture number 30. I wish I can see you in another video with another topic. Thank you for listening. Bye.